Since Tesla's first models hit the market, the promise of a truly affordable electric car has been one of the greatest desires of EV enthusiasts. For years, speculation, rumors, and subtle hints pointed to a compact, low-cost vehicle that would allow Tesla to expand its global reach. Now, this possibility is more concrete than ever with the emergence of the Tesla Model Q, a model designed to be the brand's most affordable EV and one that could redefine this segment of budget electric vehicles. The foundation of this new model lies in an innovation strategy aimed at cutting costs without compromising efficiency or performance. To achieve this, Tesla is betting on a next-generation platform, combined with advanced manufacturing processes such as giga casting and an optimized structural design. All of this ensures that the Model Q is not only cheaper, but also faster to produce, allowing the company to reach unprecedented production volumes in its assembly line. But what truly stands out is the impact this model could have on the market. For the first time, a Tesla will compete directly with entry-level electric vehicles from other brands, such as the Chevrolet Equinox EV and the BYD Dolphin. The difference? While many competitors sacrifice range and technology to cut costs, the Model Q seems to be taking a different approach, maintaining Tesla's core efficiency and innovation while delivering a far more affordable price. And speaking of price, this is one of the biggest surprises of the Model Q. With government incentives and Tesla's aggressive manufacturing strategy, the final price is expected to be under $15,779 in the United States, making it the cheapest Tesla ever produced. This not only places the car within the budget of a much larger audience, but also forces other automakers to rethink their strategies to compete with this new contender. The production of the Model Q won't just be a milestone for Tesla, it will also impact the entire automotive industry. The factory chosen to bring this model to life is Giga Mexico, one of the latest additions to Tesla's global empire. Strategically located to meet the demand of North America and international markets, this production facility has been designed to be one of the most efficient hubs in the company, reducing logistics costs and optimizing manufacturing processes. When it comes to affordable electric cars, design is not just about aesthetics. It must balance efficiency, comfort, and cost-effectiveness. The Model Q promises exactly that: a compact vehicle optimized for urban use while maintaining Tesla's signature identity. The first major design decision was choosing the platform. Initially, rumors suggested that the Model Q would use an entirely new architecture, but the latest reports indicate that Tesla opted for a modified version of the Model 3 and Model Y platform. This decision makes sense, as it allows Tesla to leverage already tested components and a well-established manufacturing infrastructure, reducing costs and accelerating production. The size of the Model Q also reflects this approach. At 3,988 millimeters, 157 inches in length, it will be about 15% smaller than the Model 3, making it more compact and easier to maneuver in urban spaces. This places it in the same category as other subcompact EVs, such as the Mini Cooper Electric and the Toyota Yaris Hybrid, making it an attractive option for those looking for a small yet efficient electric vehicle. This size reduction is not just about convenience. It's also a strategic move, as smaller vehicles tend to be more energy efficient, requiring less battery power to achieve a good range. And it's not just about length. The Model Q will also be significantly lighter. While the Model 3 weighs around 1,650 kilograms, 3,648 pounds, the Model Q is expected to reduce weight by up to 30%, bringing it down to approximately 1,160 kilograms, 2,554 pounds. This difference is crucial because it directly impacts energy consumption, allowing even a smaller battery to provide competitive range. Additionally, A lighter car means more agile handling, which is essential for a vehicle designed for daily use in busy city environments. Another interesting aspect of the Model Q's design is its aerodynamics. Tesla has already demonstrated with the Model 3 and Model Y that a well-optimized drag coefficient can significantly improve vehicle efficiency. The Model Q is expected to follow this same philosophy, possibly achieving a drag coefficient close to 0.23 CD, similar to the Model 3. This detail may seem minor, but has a real impact on range and energy consumption, especially at higher speeds. Visually, the Model Q is likely to follow Tesla's latest design language, as seen in the Model 3 Highland and Model Y Juniper updates. This means a clean and minimalist look with aerodynamic lines and few unnecessary details. The interior will likely follow the same logic, featuring a simplified cabin centered around a touchscreen display, eliminating physical buttons whenever possible. This approach not only reduces production costs, but also reinforces Tesla's identity, which strongly emphasizes digital command integration. There is still no official confirmation regarding the materials used in the Model Q's construction, but considering Tesla's cost-cutting strategy, it is likely that the company will opt for lighter and more affordable materials without compromising safety. One area of concern will be the car's body resistance to impacts, especially since smaller vehicles can be more vulnerable in collisions with larger cars. However, Tesla has already demonstrated its ability to offer high safety standards, even in smaller models, making this a key feature to watch once the first crash test results are released. Beyond its exterior and structural design, another factor that could impact the Model Q's market acceptance is its interior space. Despite being a compact vehicle, Tesla can take advantage of the absence of an internal combustion engine to maximize interior space, ensuring a comfortable experience for occupants. Models like the Model 3 are already known for their well-distributed cabin layout, and the Model Q is expected to follow the same philosophy, offering an efficient trunk space and surprisingly ample interior room for a subcompact car. When discussing a more affordable Tesla, many might assume it will have modest performance and limited range. However, the Model Q aims to change this perception, balancing energy efficiency, responsive acceleration, and a range that surpasses many direct competitors. All of this, of course, without raising the cost to the point of compromising its affordability. But how does Tesla plan to achieve this? The answer lies in battery selection and energy consumption optimization. The Model Q is expected to feature two battery options, both utilizing LFP, lithium iron phosphate, technology, known for its durability, lower production costs, and higher number of charge cycles without significant performance loss. The base version, equipped with a 53 kilowatt-hour battery and rear-wheel drive, RWD, is estimated to offer a range of 310 miles, about 500 kilometers, surpassing that of the entry-level Chevrolet Equinox EV, which has a 250-mile range. Meanwhile, the 75 kilowatt-hours all-wheel drive, AWD, version may have a range of 270 to 290 miles, 430 to 467 kilometers, slightly lower due to the higher energy consumption of the AWD system. But range alone isn't enough. Charging speed is a crucial factor for user experience. Here, the Model Q is expected to maintain Tesla's advantage over many competitors by utilizing Tesla's V3 Supercharger network, allowing for a 10% to 80% charge in about 20 to 25 minutes. This places it ahead of models like the Volkswagen ID.3, which takes approximately 35 minutes to reach the same charge level. When charging at home via Level 2, the Model Q is expected to provide 30 to 40 miles of range per hour, ensuring that most users will have a fully charged battery every morning. In terms of performance, the Model Q could be a pleasant surprise. Despite its focus on affordability, Tesla has a history of delivering agile acceleration, even in lower-priced models. The RWD version is expected to reach 0 to 60 miles per hour in around 6.5 to 7 seconds, a highly respectable time for a compact car, and even faster than the Volkswagen ID.3, which takes 7.3 seconds. Meanwhile, the AWD version could achieve sub-5-second acceleration, competing with higher-tier models like the Hyundai Ioniq 5 AWD. This level of performance, combined with a reduced weight, should result in a more dynamic and efficient driving experience. The Model Q's lower weight, approximately 2,554 pounds, 1,160 kilograms, can improve not only energy efficiency, but also handling, making it agile in corners and comfortable for daily city driving. The factor that could truly make the Tesla Model Q a game-changer in the electric vehicle market is its price. For years, Tesla has been criticized for not offering a truly affordable model, keeping its main lineup focused on premium vehicles. Now, with a target price below $15,779 after tax incentives, the company may finally deliver an EV design for the masses, competing directly with popular electric models from other automakers. But how does Tesla manage to reduce costs to this level without compromising performance and technology? The answer lies in a combination of large-scale production, cheaper LFP batteries, and a simplified architecture. Using a modified Model 3/Y platform for the Model Q allows Tesla to reuse already optimized manufacturing processes, eliminating the need to develop a brand new production line from scratch. Additionally, the car is expected to benefit from Tesla's Giga casting strategy, a manufacturing technology that reduces the number of individual body components and simplifies the assembly process, lowering costs and production time. This cost-cutting strategy places the Model Q in an extremely competitive position. Currently, the Chevrolet Equinox EV starts at approximately $28,000 after incentives, while the Volkswagen ID.3 is priced at around $38,000 in Europe. Meanwhile, the BYD Dolphin, one of China's leading entry-level electric cars, ranges between $20,000 and $30,000, depending on configuration. If Tesla successfully launches the Model Q below $15,779, it will not only be the cheapest Tesla ever made, but also one of the most affordable EVs in the Western market. However, price alone does not guarantee success. The Model Q needs to offer great value for money to attract buyers. With an estimated range of up to 310 miles, 500 kilometers, for the base version and fast charging via Tesla's V3 Supercharger network, the car already outperforms many direct competitors. For example, the Equinox EV's entry-level version has a 250-mile range, while the Hyundai Kona Electric offers 258 miles. In other words, despite its lower cost, the Model Q may still deliver superior range. Another key factor is the impact of production scale. Tesla plans to manufacture 500,000 units of the Model Q annually, with a production pace of up to 10,000 units per week by the end of 2025. This volume is crucial to keeping unit costs low and enabling Tesla to maintain an affordable price without sacrificing profit margins. To turn the Tesla Model Q into a true market success, the company must ensure that production meets demand without compromising quality or costs. Tesla's solution for this involves a combination of strategic factories, advanced manufacturing technology, and an optimized supply chain. The goal is simple: produce 500,000 Model Q units per year, making it one of the most produced electric cars in the world. At the core of this strategy is Giga Mexico, Tesla's new factory, which will play a central role in Model Q production. Strategically located to serve North America and other international markets, this facility will be crucial in keeping costs low, leveraging tax incentives, and reducing logistics expenses. Additionally, its proximity to Giga Texas ensures a more efficient supply flow, preventing production delays due to component shortages. However, Giga Mexico won't be alone in this mission. Other Tesla factories will also play important roles. Giga Berlin, in Germany, will supply the European market with an estimated production capacity of 200,000 Model Q units per year by the end of 2025. This not only speeds up deliveries to European customers, but also reduces import costs and tariffs. Meanwhile, Giga Shanghai, in China, is expected to focus on the Asian market, with an initial capacity of 100,000 units annually. This decentralized production strategy is essential to avoid supply chain bottlenecks and ensure that the Model Q can be sold globally without long wait times. Another Tesla advantage lies in its manufacturing technology for the Model Q. The company relies on gigacasting, a process that uses massive machines to mold entire body parts into a single structure. This technique drastically reduces the number of individual components and simplifies assembly, cutting costs and increasing efficiency. With fewer parts to weld and fit together, the Model Q's production time per unit can be significantly reduced, allowing Tesla to reach its production targets without excessively expanding its factories. Beyond the physical infrastructure, Tesla has also heavily invested in strategic battery supply contracts, ensuring that Model Q production is not affected by global semiconductor and raw material shortages. The partnership with suppliers like CATL and local manufacturers guarantees a steady supply of LFP, lithium iron phosphate, batteries, which are cheaper and more durable than traditional nickel manganese cobalt, and MC batteries. This ensures not only lower production costs, but also greater supply stability, avoiding the battery shortages that have plagued other automakers. Another key aspect of Model Q manufacturing is the optimization of Tesla's internal processes. Over the years, the company has refined its industrial automation systems, allowing a large portion of vehicle assembly to be handled by cutting-edge robots. This reduces the need for excessive labor, minimizes human errors, and ensures consistent large-scale quality standards. The result? A faster and more efficient production line, capable of delivering high volumes without compromising the consistency of manufactured vehicles. If there's one thing that sets Tesla apart from other automakers, it's its commitment to cutting-edge technology and artificial intelligence in driving. Despite being Tesla's most affordable model, the Model Q is not expected to fall behind in this regard. On the contrary, it could become one of the most advanced models in the compact EV category, featuring capabilities that many brands don't even offer in more expensive vehicles. But to what extent will Tesla implement its autonomous driving technology in this new model? The key to this will be the new HW5 hardware, Tesla's latest generation of full self-driving FSD computers. This system features a 3-nanometer processor, a significant evolution over HW4, allowing faster data processing and more precise decision-making in autonomous driving. This means that the Model Q could, in theory, operate fully autonomously in the future, provided that regulatory approvals allow it. However, for now, it is expected to include an advanced driver assistance system, ADAS, package, which features enhanced autopilot, emergency braking, and automatic lane changes. But what about the much-discussed full self-driving, FSD? Tesla may take a different commercial approach for the Model Q, offering FSD as an optional feature. This way, those looking for an affordable electric car can buy it at a lower starting price. while those who want full access to autonomous driving capabilities can pay extra to unlock the technology. This strategy has already been applied to other Tesla models and could be crucial to keeping the Model Q within the expected price range. Beyond autonomous driving capabilities, the Model Q is expected to feature enhanced sensors and a more efficient computer vision architecture. Tesla has been reducing its reliance on LiDAR sensors and radars, shifting towards a vision-based system using high-definition cameras. This approach will likely continue in the Model Q, ensuring a 360-degree monitoring system capable of interpreting the vehicle's surroundings with impressive accuracy. Another major technological advantage of the Model Q is its integration with Tesla's neural network, which is constantly learning from millions of connected vehicles. This means that even after launch, the Model Q will continue to receive over-the-air OTA software updates, improving performance, safety, and efficiency over time. This continuous evolution capability is a huge differentiator compared to competing electric vehicles, which often remain locked into the same software for their entire lifespan. The Model Q's control panel is also expected to follow Tesla's minimalist philosophy, featuring a fully integrated digital interface. The traditional physical dashboard will be replaced by a large central touchscreen, controlling virtually all vehicle functions. While this approach may be controversial for some, it has already become a standard in Tesla models, reducing production costs by eliminating the need for physical buttons and conventional panels. And of course, technology wouldn't be complete without connectivity to Tesla's ecosystem. The Model Q is expected to be fully compatible with Tesla's mobile app, allowing drivers to remotely control multiple functions, such as preheating the car, checking battery levels, and even activating the self-parking system. Additionally, the vehicle will likely include Tesla Vision, an internal monitoring system capable of detecting driver fatigue signs and alerting them to prevent accidents. Another interesting feature is that Tesla may introduce new entertainment and connectivity options in the Model Q, following the trend seen in the Model 3 and Model Y. This could include support for video streaming, gaming via Tesla Arcade, and even integration with video call platforms, turning the car into a true entertainment hub on wheels.